Hey guys, this video is for educational purposes only. Please do not break the law.
Hi, welcome back to Green Thumb Depot's Growers MBA podcast. Today we have a very special guest from Impello Biosciences, James Marlier, and he's going to talk to us about plant stress. What is it, and how can we modulate that stress to achieve better outcomes when we're doing crop steering? So James, I'm glad you're here. If you could just tell us a little bit about yourself and give us a background of how you got into this industry, that'd be great.
Yeah, so I worked in ornamentals for more than 10 years, doing both sales and cultivation in ornamentals. Subsequently, I went to the cannabis industry for a little more than 10 years also. I was a grower, consultant, was a sales manager for a while, did some hybridization projects that ended up becoming commercial cannabis varieties. And then after that, I went to work as an IPM manager in a commercial tomato greenhouse. And then after that, I now represent Impello at a number of cannabis facilities, greenhouse vegetable production facilities, and help people manage plant health, often utilizing the products that Impello sells.
Thank you for that, James. Appreciate it. Can you give us a little bit brief description of Impello and what they do and the products that they provide?
Yeah. So Impello, I encountered Impello when I was an IPM manager for a commercial tomato greenhouse. And I was really looking for a good monosilicic acid product. And they were very responsive. They had, as far as I could tell at the time, they had the best monosilicic acid product on the market. And they got right back to me. Turns out they do. I've put it head to head with other monosilicic acid products and it outperforms them. But then I started to kind of dive into the rest of their offerings and ended up implementing them at the tomato greenhouse. Now, Impello is kind of known as the biostimulant company, which is a particular category of agricultural products. Since then, now we actually have a 25B biopesticide offering as well that doesn't fall into biostimulant category. So I would kind of maybe refer to us more as a specialty agricultural product company, where we look at the needs of growers and the specific challenges that they have and develop products for those challenges. And we have a brilliant team of microbiologists and chemists and communicators that really target specific issues and find solutions for them.
Fantastic. All right. Thank you for that. And All right, well, let's get into it then. So we're talking about plant stress. So maybe we can just start off with what is plant stress?
Yeah. So I got to be honest, I completely ignored that question for about 20 years of my career. I took it for granted that a stressed plant is a less healthy plant. It's more prone to other pests and disease, other metabolic issues. But I never asked myself, what is it biochemically? Which for me, I don't like that I never asked that. I was a chemistry major prior to switching to horticulture, so I really should have asked. And so I started to go down this rabbit hole about 5 years ago or so. And basically, plant stress, much like in humans, stress causes inflammation. And in plants, that inflammation is defined by an excess of reactive oxygen species and an insufficient amount of antioxidants. And it's not really a metaphor in humans, other mammals, whatever. It's the same. It's just that most of our antioxidants we have to consume. So people take NAC or anthocyanins or whatever antioxidants that help them deal with the stress of daily life, whether it's the stress of work or too much sunshine. You're a surfer, so you probably get plenty of UV stress. We have to take antioxidants to cope with that, right? Plants produce their own antioxidants. So if they can't produce enough antioxidants to keep up with the reactive oxygen species that stress is causing them to produce, then they have a problem. Then they have an imbalance, and then that's a stressed plant. That's a plant that has chlorosis or burned edges or is wilting, whatever it is. There's a lot of symptoms. But you'll notice that a stressed plant, regardless of the source of stress, has a lot of the same symptomology. So you'll see chlorosis. Well, you can get chlorosis from overwatering. You can get chlorosis from underwatering. You can get it from a virus. You can get it from pythium, the wrong temperature. Well, that's interesting. Why do all of these different things produce the same symptoms? It's because of oxidative stress. All stress is oxidative stress.
Okay, so just for the broad audience that we have, would you mind defining antioxidants and this reactive oxygen species, what they are, kind of how they're produced and whatnot?
Yeah, no, that's a very important question. So reactive oxygen species are these little, basically bleach molecules that the plant naturally produces, okay? It's like hydrogen peroxide, superoxide, hydroxyl radical. There's several different ones, but they're molecules that they use for signaling, but also for self-defense. So if a virus touches a plant and it recognizes it, it's going to send hydrogen peroxide and superoxide to fry that virus, essentially, right at the location, if it recognizes that it's there. They naturally produce them. They are not necessarily bad. They have to happen. They are important for the metabolism of a plant. But then the plant also produces antioxidants to quench those, to eliminate them after they're done being used. And those antioxidants look like beta carotene, anthocyanins. There's a whole bunch of enzymes like peroxidase, polyphenol peroxidase, even ascorbic acid, which is vitamin C that all plants produce, phenolic components. A lot of them are involved in the color and flavor and aroma of plants. And a lot of them are things that we, as consumers of these plants, see as attractive to us. We look at a red fruit and think, I need that. And it's because we need those antioxidants. So evolutionarily, they're very attractive to us.
So from my background in biochemistry, when I think of oxidation and free radicals and whatnot, I'm thinking on a molecular level, essentially, an oxidative or an ROS of some sort, reactive oxygen species. Basically what it does is it breaks bonds. And
right.
If it breaks peptide bonds, so these would be the bonds that are between amino acids in proteins, that's one thing, and it can cause problems for sure. But where it really can cause problems is when it starts messing with the DNA bonds and it's breaking those bonds, because now you can mess up the code, and that can lead to things like cancer and other diseases and stuff like that. So what you're saying is in plants, the plants are actually using the ROSs as a form of like part of their immune system to knock out the viral DNA or the bacteria or the fungus, whatever it is it's fighting. But then it's got to go in there and quench the activity of those ROSs in order to stop the process, because then it's going to basically turn back on itself and start destroying the plant itself. Is that a fair assessment?
That's exactly correct. And it's the same as inflammation in us. Inflammation is healthy. It has an immune response. It's driving blood flow and oxygen to the injured area. But if it's excess, then it's actually harming the tissues, right? And so it's exactly the same thing.
It's kind of like getting a fever is good because it kills the invader that we're trying to but then if it lasts too long, it can kill you. So you take your, I don't know, ibuprofen or asprin or something like that. One of them doesn't actually break a fever. This is not medical advice. I'm not
We
a
are
doctor.
not doctors.
But okay. So a similar sort of process, but the plant's doing it all itself, because plants are completely self-contained and we are not. So they actually have some advantages on us.
We do have some antioxidants that we produce, but generally we consume most of them. Yeah. Whereas plants produce almost all of them themselves. But we can apply antioxidants to the plant as well to enhance stress resistance and resilience. Okay. So we can apply them exogenously from the outside and help, like you said, modulate those kinds of effects, which is actually really important, especially when we're growing plants in high intensity environments. Because I like to remind people that it's really nice that, everybody thinks, we're growing and it's gentle and it's this lovely thing that we're doing. Yeah, in a garden in the Pacific Northwest and you plant some flowers, that's like the gentlest environment. But we're talking about very high intensity production environments where we're asking our plants to be super athletes. They're being irrigated multiple times a day. We're getting near the peak amount of light that they can receive. We're elevating CO2 levels, and then we're doing crop steering. So we're adding stress by increasing drybacks at specific times, which is important. It's not negative. It gets our result that we want. We do the same thing with tomatoes as well. But we have to recognize that as controlled as the environments are, we are applying stress.
Right. So, I mean, essentially it's kind of like working out or
Yeah.
studying. You're stressing out. In the case of working out, you're stressing your body, you're tearing the fibers, but
That's right.
the goal is to build it back stronger. And so you want to push that stress to the point that, you know, you get the maximum value of the workout, but not to the point where you damage yourself and you're damaging your tendons and stuff like that. So you use stress. You don't want zero stress. That's not good. But you got to use it to your advantage, right?
That's right. Then you have to maximize recovery from stress. And, you know, a lot of the customer base that I have, it's greenhouse growers for vegetables, and we call it controlled environment agriculture. I like to call it semi-controlled environment agriculture. You're still at the mercy of nature. There's still going to be 100-degree days with 90% humidity outside. So what does that mean in the greenhouse, right? So there's still environmental stressors, even though we can control the environment. And indoors, even if you can really dial in the environment, you're intentionally applying stressors at specific times. But it is like working out. It's 100% that. That's a great metaphor.
All right. So what are some other ways? So, you know, a couple of weeks ago, we had Liam Spencer from Arroyo on. We talked a lot about crop steering, and we got into that. I mean, we were saying the same thing. You know, he's talking about how stress, he doesn't even necessarily like to call it stress because of the negative connotations. I think you could also refer to it in a way as like eustress or distress, you know, or there's positive stress. And
maybe we call it training.
Training, exactly. Essentially it's training. So what are some of the ways that we can use this to our advantage? I mean, I know we went over them a little bit of them, you know, so far, but are there other ways that we can do this, take advantage of it?
Yeah. So in the last several years, a lot of my focus has been on microbial diseases, fungal, bacterial, viral diseases, because they take a toll in commercial agriculture, like to the tune of billions of dollars a year lost due to these kinds of microorganisms. Now, one thing that a lot of people don't realize is that a lot of the damage caused by microorganisms isn't actually the organism itself. Specifically, when you talk about viruses, they're not doing a lot of the damage themselves. It's actually the plant's immune overreaction to the virus, overproducing the reactive oxygen species, bleaching its own tissues. And some of these viruses, it just looks like a plant got lit on fire. That's not from the virus, that's from the plant overreacting to it. So I started to kind of look at, well, how do we mitigate that immune overreaction?
Yeah, I mean, I could see some of that happening, and it's kind of, there's human analogs to this, right? Like autoimmune diseases or something. And I'm thinking how, like, I'm into probiotics and how, like, you do want some bad bacteria in your gut, a small portion, because it kind of trains your body how to react to that and kind of keeps it stressed in a way that it knows how to react. Whereas, you know, they're finding that, you know, like these children that were brought up in like sterile environments, that they have very poor immune systems and are much more prone to autoimmune dysfunctions because the immune system is not mature. It doesn't know how to react. So if it gets a challenge by some outside source, it just goes ballistic and it can destroy the body itself.
That's absolutely right. Yeah. Immune challenge is a great thing. And in plants, what that means is there's an immune challenge. It recognizes the thing. It produces reactive oxygen species. Those attack the invading microorganism, whatever it is. And then the plant goes, okay, ramp up antioxidant production, quench the ROS, and now we're good. That's the correct, healthy immune response. What often happens is that a lot of the more pernicious microorganisms, the things like Pythium and Fusarium and certain viruses and, you know, Wang-Long-Bing disease in citrus, like they actually are suppressing certain aspects of the immune system while causing a massive overreaction of reactive oxygen species. And so it's really the immune system that's doing the plant in. And what I have found is that if you can ramp up the antioxidant system during those stressor events, you can alleviate a lot of the damage. And
So how do you do that?
so what's interesting is that the more I've come to study this category of biostimulants, so biostimulants is a specific EPA category of products, right? But they don't define like what it does biochemically. They define what it is commercially and what it's made of, and what you sell it as and all of that. But what I have found is, biochemically speaking, whether it's an amino acid product or a monosilicic acid product or a bacillus microbes or trichoderma, if you start diving into the research on all of these things, one of the main modes of action is that they reduce reactive oxygen species production and ramp up antioxidant production. Now, they all do it in a little bit different ways, and they all have kind of their specialty. Like, for instance, with silicon, it's going to do that in response to more heat stress and humidity stress. So it's excellent at alleviating that particular kind of stress. Whereas with amino acid products like Lumina, one of our products, it's the amino acids themselves are actually like a precursor to antioxidants in the plant. So the plant's taking these compounds in, making antioxidants. So it's more generalized. It's more, here's a bunch of stuff to make antioxidants out of, regardless of the stress that you have. Now you can de-stress yourself. You can have an anti-inflammatory type of effect. So maybe Lumina is like the ibuprofen, I guess,
in that analogy,
to circle
right?
back on that metaphor.
Sure. Yeah, I mean, and it's kind of interesting because, when a human is fighting a disease, you need to make antibodies, and antibodies are proteins, and proteins require amino acids. So there's a lot of similarities there. Yeah.
There is. It's almost not a metaphor. It's just a different version of the same kind of symptom. It's very similar. That's why I feel very confident and comfortable saying it's plant inflammation. Plant stress is plant inflammation.
Yeah.
Stress in humans causes inflammation as well. It's really not that different.
So, one thing that I think a lot about when I think about stressing our plants out, if we want to use that word, is UV. That's right, and that's kind of one that has gained a lot of popularity to increase terpenes and increase cannabinoids and essentially trichome production and whatnot. Is there any ROSs involved with that, or how does that fit into this?
That's an interesting question. I would say, without being able to 100% say confidently, I haven't read any research on that, but I would say almost 100% certainly yes, because UV is, that's a stressful thing. But we have to remember that the cannabinoids and the terpenes are essentially, as far as we can tell with the current research, essentially a sunblock system. And also a little bit of a herbivory prevention system. That it didn't really shake out with humans because we kind of like it.
Goats too?
I guess. It's a weird system because if you produce a compound that makes the thing more hungry, that's a little weird,
Yeah. I mean, maybe originally it was like after it was seeded, it would produce the compounds that would attract the herbivores, so they would eat it and poop it out with some fertilizer,
It seems a little counterintuitive, though. Like, it really does. Like, it may be just that originally it was just supposed to taste bad. Like, I don't know if you tried to eat fresh weed, it's pretty astringent. So maybe that's good enough for a lot of animals. The after consumption effects of getting more hungry, that seems counterintuitive, but yeah. But
it can also tell a little bit about what historically the predation was, the main predation, because if you think about it, like if a cannabis plant gets exposed to UV, it's producing more trichomes. It adds to sort of a sunblock effect, right? So you're getting UV, which makes ROSs in the plant. And then you have antioxidants that are preventing that from happening. It's also sticky though, and it can really do damage to the bugs that come in there, potentially. They can't get to the plant if they can't get through the trichomes.
But they can't get away. But they can't get away.
Well, if they're really small, they just get stuck on the trichomes. But so maybe there was more insect pressure in the evolutionary history of the plant than there was herbivory or something like that.
Yeah.
Just a thought. We're going down a rabbit hole on this one.
We are indeed. Yeah, no, but I like it. So to kind of bring it back, like there's a lot of ways to alleviate oxidative stress, and it depends on which stress you're trying to alleviate and when. Because this is another thing, there's such a thing as reductive stress.
What's that? What's reductive stress? I've never actually heard that.
So, yeah, so you can have too much. So, in plants, what we're really seeking is a thing called redox homeostasis. Redox meaning reduction and oxidation. We want a balance. Okay. So, almost everything that's in existence is a redox reaction. Something is being reduced, something is being oxidized. The simplest form that everyone can recognize is a fire. Okay. Maybe fungi are a cold fire. They're reducing and oxidizing and consuming a substrate. Anyway, that's a little bit tangential, but in a fire, what happens if you put too much oxygen into it?
Yeah.
It burns itself out.
Yeah, if you don't have enough fuel for it, sure.
But if you put too much fuel, what happens?
Without enough oxygen, same sort of thing. I mean, it's got to be in balance. Yeah.
So it's redox homeostasis that we're seeking.
Yeah.
So
Yeah.
if you have a plant that's under like no stress whatsoever, and then you're adding antioxidants to it, you're going to slow down its growth.
Interesting, right? Because essentially you're taking away that stress that we were calling, exercising at the gym or something like that earlier. They're leading too cushy of a life, which kind of ties back to like what I was talking to Liam about a couple weeks ago, which is, if you create a really cushy life for your cannabis plants, they're going to love it in the vegetative state, but you're not going to get to the generative state very much.
They're going to be beautiful. They're going to be big, beautiful plants that are just very relaxed and not really doing the work that we need them to do. That's right. Yeah.
I mean, I was telling Liam how I had a vegetable garden a while back, and I was enjoying going out there and watering the garden so much. I just did it because it was fun. It was nice. It was relaxing, smoke one, go water the peppers.
Yeah.
Oh, the peppers never turned red. And I'm like, what kind of peppers are these? These are green peppers. I thought they were serranos. And then I got busy and I didn't go out there for a couple of weeks, and I went back and the plant was damn near dead, but all the peppers were red. And I was laughing at myself because, obvious reasons.
That's the perfect example. My brother, that is the perfect example. You were actually causing reductive stress by over irrigating these plants where they had no oxidative challenge to them whatsoever. So they weren't even really completing their reproductive life cycle in an appropriate amount of time. They weren't ripening. They weren't finishing anything. Yep. You were that's a perfect example. You were causing reductive stress in that
and
situation.
They were basically like, well, I'm going to live forever. In this case, I don't need to produce peppers and seeds and all that crap, and go out on dates. So yeah, it's really interesting because I think, sometimes even though we do have a lot of this knowledge, sometimes our innate sort of reaction and how we go about things, if we're not really thinking about it, we might be doing something that's counterproductive to what we're trying to accomplish in the end.
100%. Understanding the core, for me, in this life, the why is so much more important than what. It's so much more interesting. And so going down this rabbit hole of what is oxidative stress, which, by the way, I just want to throw this out there. Reductive stress is so much less common than oxidative stress. Reductive stress is you took too good a care of your plants. How many people that's the issue? Not really often the issue. Oh, the environment's too good? Come on. So, especially when we're in like a production situation, we want to be able to apply targeted amounts of stress at specific times for specific reasons. And then when there's other kinds of stress that we do not want to negatively impact the plant health, we need to apply either certain techniques or certain products to alleviate that. That's the goal of understanding why, is that then you know what and when.
Absolutely. And, I'm thinking about it now as you're talking, and I'm thinking about everything we do to crop steer and how, in a way, it's all a sort of limited form of stress, right? I mean, even the photo period, like when you cut the photo period, that's stressful. They're not getting as much light.
Oh my God. The way that we do it.
The way that we do it. Yeah. 18 and 12.
Bang. 12. Like, that's insanity.
Right? right?
Imagine you lived your life as a summer day, and then it was September 21st all of a sudden, and you're going, what? Like that? It's insanity. It is for sure a stressor. Yeah,
Yeah, yeah. And with humans, when the seasons change, it's a stressor on our immune system. A lot of times when
for
we
sure.
get sick, it's when the seasons are changing because the antibodies that we need aren't being produced as well because of the heat and whatnot, other factors, and there's other factors involved there, but interesting.
Well,
Okay.
even just so Chinese medicine talks about the six evils, and one of them is cold drafts. And then for the longest time, Western medicine said whatever crackpots, and then they found out, oh, when the tissues in your nose are even 3 to 5 degrees colder than the rest of your tissues, it makes rhinoviruses far more likely to propagate in the tissues of your nose. So it turns out cold drafts actually do make you get a cold.
Yep. Yeah.
Oopsie daisy. Yeah.
And I don't know how much validity there is to this, but I've always thought that the flu season, the cold season, when everyone gets cold in the winter, a lot of it also has to do with drying out the membranes, right?
Oh,
Because your mucous membranes, when they're moist, things can't get through. But you go into a condensing atmosphere, which is where you're at in the fall, right? And all of a sudden everything's all dried up, and the
this guy's
virus.
now you're bringing up VPD for humans. That's what you're talking about right now.
That's where I'm bringing it home. Exactly.
I
VPD.
have not considered VPD for humans, and I think you're onto something.
Yeah, and I'm wondering how that affects the plants too, because
For sure.
I mean, VPD is one of the biggest things when we're crop steering, and that is
Yeah.
a form of stress, like how you
Yes.
modulate that. And of course, we know how it affects the water flow through the plant and everything, but I'm wondering for other stressful events, how is that going to make it worse, or are there other things that we can trigger inadvertently by modulating the VPD? Maybe if we understand more about it, like, and even like the photoperiod, when we cut the lights, when we flip it,
Yeah.
like, what kind of stress is that plant going to undergo? Obviously we want them to flower. That's one form. That's great.
Sure.
But is it causing anything else that maybe we want to like get ahead of and try to mitigate before we see it happen?
I have a working hypothesis, but I hate stating anything as fact because I mainly see the world through the lens of science. Like mainly, I'm a bit of a superstitious person, but that's a whole nother box of frogs. But for this, I look at stretch period as a second veg, and maybe even more important than veg. I don't know, maybe, but or just a close second. Like veg is where you build the organism, right? Well, stretch is your second opportunity to build the organism. It's going to double in size, certainly more than double in mass. You're building the structure, let's say the skeleton on which you're going to pack meat after that, right? So what I think is, and what I typically did when I was cultivating this particular plant was I like to do a foliar feed and a drench with biostimulants, chelated nutrients, and all of that, like just before I move them into flower, because I know we're going from 18.6 or some folks 24. I don't know, diminishing returns on that. Anyway, we're
yeah, we're going to start a whole controversy just on that.
my bad.
No, I like it. I like it. It's great.
Anyway,
we'll get
we're
a
going
lot more
from
comments.
let's just say long days. Let's go
Yeah.
long days.
Okay.
To short days abruptly.
Yeah, real abruptly.
Shock to the system. Okay, and we're putting it in a new room. The humidity is automatically going to drop because there's not as much plant tissue per square meter in there. So even if you have really good climate controls, like there is going to be a drop in humidity, especially because you're taking plants, moving them through a hallway into another room. Like it's not ideal. This is a shock. We have to remember that these are stationary creatures and we're moving them. They don't like it. Okay.
Yeah.
And ostensibly, most of the time, they're under a different spectrum of light.
Yeah.
Also, there's all kinds of little things that we shift, right?
I was
Also,
just talking to a light expert that was saying changing spectrum he doesn't recommend it at all. I mean, I'm not sure, I'm not saying I agree with all of it, but he was talking about the stress that is induced by changing these spectrums, and a lot of the spectrum tuning may be counterproductive.
That's a conversation to have. And I don't know which side of the argument I would be on, to be honest with you. But let's recognize that 99% of the time, there's that stress as well.
Yep.
So we're changing humidities, we're changing plant densities, we're changing light spectrum, it's a whole thing. We're shaking them around. And for me, when I was growing, I would lollipop them right at that time, get rid of all their lowers to make sure they focused on the tops.
Right when you flipped them.
Yeah, I would do it right before I moved them into the new room, because the lowers are where, pest and disease very often start. So I just get rid of that, and I make them concentrate their energy towards where I want them to go anyway. But I recognize that's a big stress, so I foliar feed them with some calcium, some stabilized silicon, some microbes, and some amino acids.
Yeah.
I'm going to alleviate all of their potential stressors. Hey, everybody, just relax. I know I'm doing some crazy stuff to you right now. Because for the first 21 days of a typical commercial variety, I need that 21 days to go flawlessly. If it doesn't go flawlessly, I'm leaving yield on the table. So I'm turning lights down. I got high humidity. I did a foliar feed before I moved them in. I need them to be comfy. That 21 days, I want it to be so comfortable that they just explode. That they just feel the, just explore the space. And then this is, there's a lot of different ways that people talk about crop steering. I'm not saying I'm 100% right. This is just what I did. At day 21, I defoliate everything. I start doing harder drybacks. Maybe I'm irrigating 6 or 8 times a day. I'm doing 20-25% drybacks between irrigations. The plant thinks there's a giant herbivore in here who's eaten all of my leaves. I now have insufficient water and nutrient resources. I have to reproduce.
Yeah.
I'm an annual. I'm not a perennial. I have to reproduce. The next generation is the most important thing. Grow flowers to make seed. And I do that for a week. And during that week, I wouldn't apply any kind of biostimulant. I wouldn't apply any kind of anything to alleviate that stress. I want that stress to be felt. This is weightlifting. This is sprints. This is an inflammatory action, right? And then at day 28, I go, I was just kidding. You can have all the water and nutrients you want. I'm sorry. Here's some amino acids. Here's some silicon. You're good. But they've already switched their metabolism to go reproductive.
Sure.
And then they get thick after that.
Nice. Interesting technique. Yeah. Yeah. It makes a lot of sense though. Stress them when needed to get them to go in the right direction, but don't stress them too long, too hard, or you're going to cause problems. And try to alleviate other forms of stress that aren't going to be productive, especially in that stress period, that intentional stress period. Because, if you're flipping them or defoliating, something intentional, and at the same time they're trying to fight off some, pest or something like that, I mean, they're gonna have a hell of a time making that work.
And we can get into this, and I would love to go on a deeper dive with the IPM stuff, because for years, the last cannabis facility that I ran, we were completely pesticide free. And I use finger quotes because what does that mean? A pesticide is anything that takes care of pests. So are biologicals pesticides? Are biostimulants pesticides? Well, no, not by legal definition, but
if you put the claim on the bottle, that's all it is, right?
See?
Oh man!
Hold on. Legal disclaimer: biostimulants are not pesticides. I would like to say that
Yeah, no, they're not, and they don't make those claims on the bottle. And
There you go.
there you go.
But
Now,
also,
how you
but
use them is a whole different. That's up to you.
and if you, yeah, exactly. And a little bit of water. What if is my thumb a pesticide if I go and rub off some aphids off of my tomato? I mean, by definition, but legally, no. Okay, hold on. I really got in the weeds there, so to speak. What I think is when you're trying to do those massive like vegetative growth phases, whether it's in veg, which by the way, periodically in veg, a little hard dryback sometimes is really great, right?
Sure.
It makes them root out harder, just periodically, just a little bit harder dryback. Bang, you get some roots and less floppy plants. But the 3 weeks of stretch for conventional production plants, you better make that thing comfortable. Make its life so easy. I like to turn the lights down a little bit when they first come in, especially because that helps the humidity stay higher because you're not cooling so hard. You've just hit them with a foliar of Dune and Lumina, and you're giving them chelated calcium. You're making their lives so easy until you tell them, I want you to stop growing vegetatively. You have a stressful environment. You have to reproduce. And I feel that day 21 is the magic number for that. You defoliate, start doing hard drybacks, and you give them a week of stress. Now, it's important that at that point you've already managed all your pests and disease.
Absolutely. I get into this dialogue with folks all the time where they're going to be spending thousands of dollars on flower lights, and then I'm like, all right, so what are you doing in your veg room? They're like, oh, I just got some cheapy Chinese stuff off Amazon. It's fine. It's just veg. And I'm like,
okay.
And I say, look, you can do what you want. I'm not trying to tell you what to do, but you want to make sure that those plants are in an ideal scenario when you flip them. And if you don't have the right lights, the right newts, you might not notice nutrient deficiencies or other problems in the plants and veg because a lot of the other factors are pretty cushy. But as soon as you flip them, and now they have the stress of getting flipped, all of these things,
environment, an intense environment.
Yeah. And they're going to, all that stress, you're going to see all these things all of a sudden come up, and you're going to be fighting against these deficiencies and maybe pest
That's not
pressure.
the time.
In flower, that is not the time,
That's
not at
the
all.
time. Listen, I'm going to make the metaphor again of the athlete metaphor. Again, we're asking our plants to be super athletes, okay? These are not a backyard. I planted it next to my tomato in grandma's soil that's been cultivated for 30 years. That's a cushy life. That's beautiful. They got marigolds. They got parasitic wasps just hanging around doing their thing. They got all the love, okay? That's not what this is. We're training for a fight. Flower is the fight. If you didn't do your training camp correctly, you're going to get your ass whooped.
Yeah. Yeah.
That's the training camp.
And when you were talking about outdoors, I'm just going to put this in there too. One of the methods that plants alleviate stress, especially pest insect stress, is they release volatile organic compounds that will attract the predator to that insect that's eating on them, that's predating them. And, so there's all these complicated mechanisms, but when you take that plant and you pull it out of this ecosystem and you put it into a room with artificial light and a monocrop and artificial lights, and there's, it's essentially, when it comes to insects, unless you intentionally introduce beneficials, it's a sterile environment, right? And so, that poor plant, it might be getting hit by aphids and it's screaming molecularly, right? With it's emitting these molecules saying, come, ladybugs,
it sounds like this.
Yeah, exactly. Swerskis, come get me, come help me out. And nobody hears their cries, And so we've got to step in with the biostimulants at that point or other methods to help them out because we've removed them from their ecosystem, from their friends that help them do this.
That's right. 100%. And I think that we're probably going to have a follow-up on this where we talk about IPM and timing and all of that because
definitely.
Listen, I didn't even think it was possible when I first started growing cannabis. Coming from the ornamental industry, I didn't think it was possible to be pesticide free.
Mm.
I was wrong. The last facility that I ran, excuse me, we were free of pesticides for years, and I was using only biologicals. And also, I mean, it's a little bit of a weird thing to say because I was also using trichoderma and bacillus microbes and things, but they were biostimulant versions, not pesticide versions. So that's more of a legal definition kind of.
Hey, this is the world we live in, I
Yeah,
mean, it
yeah,
is. Yeah.
right.
It's really interesting because something can be regulated entirely differently
Yeah.
just based on what you call it, the claims you put on the label, but it's the same thing. Yeah.
But my goals were the same and the
Yeah.
results were the same. So it's, yeah, but I was proud to be able to say, listen, I'm doing all the pest and disease management with this biologically,
Yeah.
and that's that. And it makes for a better product, for one, like taste wise.
Definitely.
You could get more esoteric than that as well, but at least taste and aroma wise, not spraying oils and stuff like that on your plants, that's going to be a lot better product.
Back in when I was at that shop, it was 2016, and it was like cowboy days. People come in, they're like, Ellie, I'm in week 6. I'm going to week 7. I got PM everywhere. Give me some Eagle.
No.
And I'm like, get the hell out of my store. Because, I mean,
stop talking.
Don't
do that.
I'm like, I'm not selling you Eagle 20. Get out of here. I would never use it. I've never used any pesticides.
Sure.
Nothing. I've never even used any pesticide. I've never had an issue. You do it through what's protocols. The best pesticide is protocol. Like, have the sticky mat, have the positive pressure, like avoid the problem in the first place. Then you save money.
That guy who grows at home, and every time he does defoliation, 7 days later, I have a freaking spider mite outbreak. Oh, it's you? Oh, okay. Now you're on the trim team.
I used to grow with my bro, and he wanted to work with another guy at another spot. And I said, if you do that, we're done, because I know you, and you're going to bring it back, and you're going to bring PM in here, because they were dealing with PM over there. I'm like, no, we've never had PM here. I'm not doing it. And then he did it, and then he brought PM back, and I'm like, okay, I'm done. It's your problem. I'm not growing anymore. Not with you.
Okay, so what I figured out was, because I had, at the last cannabis facility I was in charge of, I had it down to, I want to say 4 touches. So in the ornamental industry, we talk about touches. How many times do we touch the plants? Yep. Now, in ornamentals, it's really a focus on labor, right? Because labor is the most expensive aspect of any organization, but especially agriculture. How many times have we touched the plants? And that includes moving them, transplanting them, spraying them, freaking whatever, right? Any irrigation that doesn't happen with an automated system, touches. I had it down to 4 touches from propagation to finish. Okay, that's beautiful.
For any ornamentals, or
no? I'm sorry. This was for cannabis.
Oh, this was for cannabis. Okay.
Yeah, this was for cannabis. I had it down to 4 touches. I think I could have gotten it to 3. Anyway, because humans are mobile contamination units. They're MCUs. All right.
I like it. You heard it here first.
Well, actually, no. This comes from Paul Stamets in Growing Gourmet and Medicinal Mushrooms, a book I read when I was 16 years old and changed my whole perspective. All right. And he calls humans mobile contamination units. And that stuck with me. We're covered in all kinds of yuck. Okay. So the less we can interact with the plants, the better.
Yeah. No, that makes a ton of sense.
But there are times where you have to, like, for instance, cloning. Okay. Transplanting out of cloning. Okay. Shifting from veg to flower and simultaneously lollipopping or whatever. And then defoliation at day 21. Okay. So because I was consistently during those exact time frames populating the canopy with predatory mites and things like that during those times, it's totally fine. But the day 21, between day 21 and day 28, I would always notice that on day 28, I would start to see spider mite, two-spotted spider mite hotspots. And I went, that doesn't make any sense. I've been using Californicus since the cloning level, and this is going to definitely transition into the next thing where we're talking about IPM and what have you. Why does it pop up there? And I realized it was my humans. So, I mean, you got a team of 4 or 5 people in a few hundred or a few thousand square foot grow room, whatever. They're touching every single part of the plant to do defoliation, right?
Yeah.
I realized that at least one of my people were contaminated with 2-spotted spider mites. Now, the other thing that I learned from, I can't remember which insectary it was, but after about day 14, day 21 in flower, there's too many trichomes on the plant to where Persimolis and Californicus and these predatory mites, they don't really travel well on the plant because of the trichomes. Which is true for tomatoes also, by the way. That's the reason why predatory mites don't work well in tomatoes. There's too many trichomes. They just can't navigate well. And I went, okay, well, then what if I used my humans as a distribution system?
So take a ladybug bath? No, what do you...
Well, so what I did is you get the Persimolis and your vermiculite, and I just would put like a couple teaspoons of Persimolis in the pocket of the scrubs of each of my defoliators. Just put them in their shirt pocket.
Did it work?
It worked amazing. I never had a problem again.
That is genius. That is genius.
I never had a problem again. It worked amazing. They're touching every single part of the plant. And I had one employee that said, I don't want mites on me. And I said,
you already do.
You already do, bro.
You already do.
You already do. You just got the wrong ones.
That is amazing. That is a form of predatorial jujitsu. Because you're saying, okay, I'm going to take this MCU, these humans that are spreading the disease, and I'm going to use that for the power of good by putting the predatorial mites. That's honestly, right. That's one of the coolest stories I think I've heard in a long time. I love that. You got mites on you. We all got, and even if you're not a cultivator, we all have other mites on us, just human mites. I mean,
all kinds of mites.
Dude, there's more bacteria and mites and fungus on the surface of the human body. And I mean, people have no idea. And if you don't have them on you, then you start having some problems.
You got problems.
Obviously you could have bad ones, but there's just like anything. There's good stuff and bad stuff. You just got to cultivate the good stuff. You're not going to be sterile. And if you were sterile, like you'd be in a world.
That's a problem.
Yeah,
that's a problem. And that brings us back to like Tribus, for instance.
Let's talk about Tribus.
Because there's no such thing as sterile. You think you're doing an abiotic grow, you're wrong. There's no such thing as a place where microbes don't exist. This is not a, you didn't grow these plants from tissue culture in a HEPA filtered, positively pressurized environment where you're periodically putting ozone into it, and the media that you brought in came from an autoclaved, sterile. Come on, this is ridiculous. There's microbes everywhere. You cannot sanitize your way out of having microbes.
Absolutely.
You cannot do it. So what we have to do is we have to think of the root zone, so the rhizosphere and the phyllosphere, which is the foliage. We have to think of it as a stadium. Okay? And we need to populate all the seats in the stadium with the good guys. There's these surfaces of these tissues. There's no such thing as not having them populated with microbes. There's no such thing as that. And by the way, the plant is secreting all of these metabolites, and a lot of them are sugars
Yep.
And those are very attractive to microbes. So we need to populate those surfaces with beneficial microbes that eat up those sugars and make it so that things like Pythium, Fusarium, the what have you, they just can't populate those seats. There's good guys in there eating up all the sugars, and we can't make pesticidal or fungicidal claims, but like they don't like each other.
They outcompete.
They outcompete.
Yep,
And
absolutely.
so we populate them and we go, cool. And if we have a very good environment where there's ample water and ample oxygen, they're going to outcompete the bad guys very seriously, right?
And the right temperature too, of like your
Uh,
nutrients and stuff. I mean,
for
that's
sure.
why you want to keep your newts at 68 approximately, and you want to oxygenate, because if you keep it cool and you keep it oxygenated, you're going to preferentially select for beneficial microbes. Stagnant, low oxygen water, that's where all the bad guys live. So you
That's
know,
right.
and that's why when you're brewing tea, what are you doing? You're keeping it chilled about 68 or so, and you got an oxygen, a waterfall or some bubblers, something. I prefer the waterfall, but it keeps it nice
It's
and
better.
oxygenated and cold. It is better, right? And
It
it's
is.
easier. You don't have to clean the stones. I mean, who wants to do that? That's
But
gross.
also, if you just think of like a ratio of like oxygen to water, if you're submerging a tiny thing that's putting a little amount of air or oxygen into a mass of water, that's not doing as good as there's a little amount of water and a massive amount of oxygen surrounding. So waterfall is a more efficient oxygenation strategy. And to your point, the beneficial microbes much prefer an aerobic environment.
Exactly.
And at those temperatures of 68, oxygen is far more soluble in lower temperature water than it is in higher temperature water. So nailing the temperature is critical as well.
Yeah, absolutely. And that's the sweet spot between like 66 and 68, because you're getting maximum gas dissolution in the liquid. But if you go cooler, now you're going to start affecting the plants because it's a little cold. Now, you might want to go cooler if you're in week 8. You're just saying, finish up, ladies, you're done. You can get pretty cold. You
That's
know,
the
it's
wrap.
another, it's a stress, it's a crop steering event, these types of things.
Yes,
But in the general sense, 68, 66 to 68 is perfect for that.
totally
Now,
agree.
going back to what you're saying about a sterile environment, I've had this conversation with more growers than any other conversation lately. Is there's a certain company out there that kind of popularized bags of salt in this industry. Now, it existed a lot earlier, a lot longer than just in this
Sure.
industry. But one of the things that was popularized with that is hypochlorous acid and sanitizing, and doing that between runs, sanitizing, sterilizing. That's great, but sterilizing your rhizosphere with hypochlorous acid, I don't recommend
Wait,
it. And it's
hold
not
on.
sterile. And what you were saying, it's not really sterilizing. What you're doing is you're knocking down a majority, but then you're making it available, those seats available to whatever bacteria lands in there. And if you're not inoculating, then you're leaving it to chance. And it's the same thing as taking a bunch of antibiotics, killing
Yep.
everything in your gut, and then when you get off the antibiotics, not eating your yogurt or your kimchi or
You're
your
going to get
kefir
sick.
or your right, and then you might be okay, but you might pick up a bad bacteria. Now your gut has been repopulated with a Helicobacter pylori, and you got to go take some more antibiotics to get rid of the ulcers that they're causing. And it's a world of hate. And all you got to do is have healthy bacteria in your gut. And the same
Smokey,
thing with
my friend,
plants.
you're entering a world of pain. All right. So, but to your point, so this is one of okay, so I run into this in both the cannabis sphere and also controlled environment agriculture for vegetables as well, because hypochlorous acid is quite popular in that realm, as well as hydrogen peroxide. And here's what's interesting: they're not mutually exclusive tactics. They seem like they would be, but to harp on what you were saying, there's no such thing as sterilizing your environment with what, the 5 maybe 10 parts per million of hypochlorous acid. That's not sterilizing, that's sanitizing. Okay, that's reducing the amount of microbial load. If you were to apply enough hypochlorous acid to sterilize the environment, your plants would all be dead. And That's fine. If you don't have any plants, you don't have any microbes either. You don't have pests and disease, but you also don't have plants. And we are trying to have plants. So part of the reason for Impello to focus on bacillus species is that they're extremely tolerant to harsh environments. And the rule of thumb, and it sounds oversimplified, but the rule of thumb is if a plant can tolerate it, bacillus microbes can tolerate it. Because they've co-evolved for so long. The microbes in Tribus and Continuum, both of our flagship bacillus micro products, they can tolerate up to like 31 parts per million of hypochlorous acid. No one's doing that to their plants. No one, you shouldn't.
Potentially.
It's a huge mistake. You're causing massive oxidative stress to your plants at that point. But at the normal levels, at the like 3 or 5 parts per million, yeah, things like Pythium and Fusarium and stuff, they're pretty susceptible to that. But bacillus microbes do not care about that. So we have seen them function very well in conjunction with sanitizers like hypochlorous acid, hydrogen peroxide. And then what you're getting is multiple modes of action.
Huh. Okay. Yeah, I've wondered about that because I have heard that exactly what you just said about them being tolerant. And so it's
Yep.
okay to use inoculants with that. I thought maybe it was more referring to the sporulated form of the bacteria because obviously sporulated bacteria are bulletproof, right? So,
Bullet.
yeah. So I thought that it was maybe that was the cause. But what you're saying is even the live bacteria, the strains that are beneficial, they're not going to be they may be knocked down a little bit, but they're not going to be
Yeah.
knocked down to the levels that the pathogenic bacteria will be.
That's very well said. That's very well said. It will knock them down to some degree. And again, when I reference 31 parts per million, that's the sporulated form. It doesn't care about oxidizers. 450 parts per million of hydrogen peroxide doesn't kill the spores of these bacteria. 450. That's crazy. You should never put that on your plants. That's wild. So they're very durable, but at the normal levels of using hypochlorous acid, these microbes are still going to thrive. It might slow them down a little bit, but they still thrive. Yeah.
Yeah. So what I would recommend to folks is if they're going to use hypochlorous, now I would always kind of recommend using drip clean to keep your lines clean and just keep
Sure.
your beneficials in there. But if you are going to use hypochlorous, just do that, wait a day or so, and then inoculate after that so
Sure.
that at least your beneficials aren't going to be just dumped right in at the same time or just before that.
Yeah.
Yeah.
I completely agree with that. And that's just kind of good practices in general. Like we sanitize the hell out of a room after we harvest and clean it out. And then we repopulate it with beneficial insects, beneficial predatory mites, beneficial microbes, same kind of thing. Like clean it down, put the good guys in.
Yeah.
It goes back to the metaphor that you were talking about. Like, okay, sometimes you do have to take a round of antibiotics. But then after that, you're going to drink your kefir or your kombucha or your whatever and exclude the bad guys.
You got it. That's it. The key to a good life. And a lot of people, they don't just a little bit about probiotics because there's some similarities with plants too, is having a healthy gut population of gut bacteria. It doesn't just keep bad bacteria out. It helps with nutrient absorption. It helps with your mental state. Many people don't realize that there's more neurotransmitters made in your gut by these bacteria than there are in your brain. The biggest nerve coming out of your brain is the vagus nerve, goes right down to your gut. And if you've got the wrong bacteria in there, it's going to cause you, nowadays they're linking things like bipolar, schizophrenia, potentially to bad in their gut. And so, yeah, plants don't have the nervous system, obviously, but nutrient absorption, they have their own mechanisms, their own pathways. And they have been evolving with all of these microbes in the rhizosphere. And if you eliminate them, there's going to have an effect. And you 100%. Might be able to achieve the same result. Like, let's just take nutrients. If you have a somewhat sanitized root zone with not a lot of beneficial microbes, you might have to add twice as much fertilizer to get a similar effect because the nutrients aren't being absorbed as well as if there was microbes there. Now, there's other things to it. You can add chelators and whatnot, but bacteria, they make their own chelators, right? I mean, they make things more bioavailable. So I'm always more of a fan of adding beneficial microbes that make the enzymes that do the positive effect rather than just adding the enzymes themselves. Because if you add the enzymes, they have a half-life. They're going to decay over time. You got to add them again. If you add the microbes, they're reproducing, their biology. They're going to keep producing over time. You might want to keep inoculating, but
Sure.
you don't have to add as much because they will take care of that themselves. Their life. That's what they do.
That's right. And what we have found from doing like qPCR tests on so many root zones, from so many different kinds of plants, realistically, depending on the speed of the growth of the plant and their root production, somewhere between 2 and 4 weeks is about your reinoculation schedule. That's about it. They're in there actively eating the root exudate that we talked about before.
Yeah.
They're feeding on those sugars. They're reproducing on the surface of the roots. And to your point, phosphate is one of the things that gets tied up a lot because phosphate reacts with calcium. We're feeding our plants tons of calcium, which specifically for cannabis, but also tomatoes and pretty much everybody. Calcium is hugely important. Excuse me. Calcium phosphate is totally insoluble. It's what our bones are made out of. Not soluble stuff. But the microbes, the bacillus microbes in Tribus and Continuum, solubilize that phosphate and make it more available. And because we're pumping so much of it into our plants all the time and into our media with evaporation and a lot of it gets built up. That's where you get nutrient lockout and this and that. So these microbes play a big part in making sure those things stay soluble, both calcium and phosphorus. A bunch of other ones as well, but those ones are the ones that tend to lock up.
So let's talk a little bit about these products. Because honestly, I do feel that Impello makes some of the best products out there in this
I agree.
category. So and a lot of people agree. I mean, Tribus, so many people have heard of that product. And now most people think that's the name of the company. A lot of people don't recognize the name Impello, I've noticed. But when you say Tribus, they go, oh, I know Tribus. So
Interesting.
tell me a little bit about Tribus. Like, okay, I mean, obviously I know about it, but tell our viewers, like, what's in it and what do those components do?
Yeah. Okay. So Tribus was it kind of makes sense that you're saying that people recognize that more than the name of the company. That was our flagship initial product. And then that predates me as well. It's a combination of Bacillus pumilis, amylo liquefactions, and subtilis. Sorry. Bacillus subtilis, Bacillus amylo liquefactions, and Bacillus pumilis. All right. And individually, all of these organisms are great. They work great. There's a lot of products out there on the market that are just one of these bacteria. Okay. But what our researchers found was that when they exist as what we call a consortium, they facilitate each other's growth and plant health in ways that one of them cannot do. They outcompete all kinds of organisms that we don't want around. They solubilize nutrients. They produce these things called secondary metabolites, which are basically compounds that aren't necessarily necessary for the life of the bacteria. It just so happens that they boost growth and health and vigor and yield of plants. And that's because they've co-evolved for millennia with plants. And we discovered these particular versions of these bacteria on very healthy plant roots and isolated them and then cultured them together and realized, oh my gosh, they work so much better together. And then after that, we found out that because Tribus is kind of cultivated in a more traditional way, like we grow the bacteria separately in their own vats, and then we centrifuge them and combine them. Okay? Works great. What we found was that when we co-fermented them in the same vat, there's a lot of crosstalk between the microbes. And while they do support each other's growth, they do compete for resources. And so they secrete more of those secondary metabolites that benefit plant health, benefit plant growth. And that's where we came up with continuum, which is all of these microbes co-fermented together. And then we don't centrifuge that because we want to keep the broth. The broth itself, where they're secreting these compounds, have amazing effects on plant health and growth. So that's continuum, which is Tribus 2.0. Like, Tribus works great. Don't get me wrong. It works fantastic. People love it. But continuum is demonstrably better because we co-ferment the organisms together.
And I think there's an extra strain in there too, isn't there?
There is. There's a completely different species called Pinibacillus chitinolyticus. And the species name on that, chitinolyticus, kind of divulges a little bit of what it does. Chitin is a compound. It's the second most common polymer on the planet, right behind cellulose. It's what fungi are made out of. It's what crustaceans are made out of, insects. It's what their shells and stuff are made out of. And lyticus basically means dissolves. So it produces an enzyme that dissolves chitin. And that's all I'll say about that because of things.
Yep. Because regulations and stuff.
Because labels.
Labels. Bureaucrats. Yeah.
Yeah.
Exactly. And an interesting fun fact about chitin and cellulose are almost identical. It's just the sugars are connected this way in cellulose, and then they're connected this way in chitin.
No shit.
Exactly. Yeah. Check it out.
Okay.
Yeah.
All
So
right.
it's not surprising that they're both used for structure, that one is the most common, one's the second most common. Makes a lot of sense. Yeah.
But everybody considers, well, not everybody, but let's say the fancy pants scientists who make these decisions have previously, up until this point, considered silicon a non-essential or quasi-essential element for plant growth. That is ludicrous, and the way you're shaking your head tells me that you also know this, and anybody who's ever used silicon in their plant nutrient regimen also knows silicon, let's call it essential. And by the way, recently, in the last few months, I'm trying to remember the acronym of the organization that has deemed silicon as an essential micronutrient for plants. This just happened in the last 6 months. Which, welcome to the party, guys. You figured it out. Like,
Right.
Okay, great. The growers already knew. Okay. And I think a lot of plant diseases and deficiencies and all of that are really actually just a silicon deficiency.
Sure. Because plants that have enough silicon, I mean, they can really fight off the pest pressure. It's like our skin, right?
Yep.
If we walked around without skin, we wouldn't last very long.
Check this out. So one of the things, this is another rabbit hole I've been down for years, is that there's this little known thing in plants called phytoliths. And phytolith literally means plant stone. Okay.
Yeah.
They also refer to it as biogenic opal, which is a way cooler term, I think. The biogenic opal, I mean, come on, what are we talking about? There's precious stones inside our plants. Yes, there freaking are. And when monosilicic acid is absorbed, the plant uses it. It has this like antioxidant effect, and it creates all these like biological, biochemical effects. But then when they finally deposit it, they deposit it in and around their cells as these things called phytoliths, which you can actually identify in the fossil record in soils which plants were growing at that level, because they're like snowflakes. Each different species of plant makes a different form of phytoliths, and they're silica, so they're glass, and you can identify like what plant was in that layer. But the point is, they're these beautiful little snowflake-like shards of glass in between the cells of the plant. So when an insect that's chewing or burrowing or sucking, it's kind of like you have diatomaceous earth within the plant.
Yeah.
And it wears away its mouth parts. If it's a burrowing one, it scrapes it's terrible for their health. I can't make pesticidal claims, but it is terrible for their health.
I remember seeing some electron microscopic pictures of these insects with their mouth parts. And the only thing I can say is, as soon as I looked at it, I'm like, man, these all look like a bunch of tweakers with they're missing their teeth.
They
They
chewed their teeth out. Yeah.
And I mean, the thrips, their little, whatever you call it, their little tube is like all bent.
Yeah.
And the other ones like aphids, they got no mouth part. It's all ground down. Like you could see all the serrations on the one that didn't do it. And then it's just round. It's just smooth. It's like, I was going to say they're gumming the plants.
They're gumming it. It's not real effective. Yeah.
So yeah, silica. I mean, it's huge. But
frankly, to be honest with you, Dune is, look, I'm partial to it. I sell the product, obviously, but I came to that product well before I came to work for this company. I was using it in a commercial tomato crop. It was the best monosilicic acid product I came across. And since then, I've done side-by-side comparisons in commercial greenhouses and grow rooms. We've done tissue tests to demonstrate how available it is, how much is absorbed into the tissues. I'll say right now, Dune is the most bioavailable, potent monosilicic acid product that's out there. And if you don't like that statement, then we could either get into a parking lot fist fight, or we could do a side-by-side comparison and do some tissue tests. Either way, I'm fine with that.
Right on. And just for all the folks that don't understand, because a lot of people do understand monosilicic right now, but I used to use, back when I was a newbie, right, I used to use GH. It was silicon dioxide, right? And it's like, for people that don't understand, please, what's the difference? Monosilicic versus everything else silica, there's a big difference.
Absolutely. And the labeling doesn't help clarify that, by the way, because may take a moment. All right. So the only form of silicon that is bioavailable to plants is monosilicic acid. It's the single unit of silicic acid. It is one unit. Anytime you're using some other compound of silicon, it is polymerized. So there are a bunch of units of it stuck together, and therefore it has to be weathered, which is to say microbes and chemicals like break it down and make it available to the plant. So silicon dioxide, that might be the least available. Well, it's up there with clay. Clay has silica in it too, but it takes ages for microbes to free up some monosilicic acid from it to become available to plants. Okay. Sand, same way. Slowly, ever so slowly, microbes are freeing up sand particles and breaking them down a little bit and giving some of it to plants. Even rock wool. Rock wool is an aluminosilicate, so it has silicon in it. And if there's microbes in there, they're slowly weathering a tiny fractional amount and feeding it to plants. I've seen it on tissue tests with plants that are grown in rock wool that don't have any silicon feeding, but they have a little silicon in the tissues. It's from the rock wool. Okay. But if you want to have a potent effect, if you want to get the right amount to your plants, the only version that's completely bioavailable is monosilicic acid. And if you're feeding something that's like a silicate, it's polymerized. If it's potassium silicate, or worse yet, sodium silicate, why are you putting sodium into your plants? Anyway.
It's cheaper.
Well,
sodium silicate is cheaper than potassium silicate.
My brother in Christ, that's for making ceramics.
Hey, I'm with you. I worked for a variety of companies, and I know a little bit about the kitchen behind, and I've asked the same question, like, why sodium? Oh, that makes sense.
And then I would say, like, one of the other ones would be like calcium silicates, like wollastonite, that kind of thing. And that's cool because it has calcium in it. But again, it's going to take 6 to 24 months for it to decompose in a biologically active soil and feed that amount of silicon to your plants. So you're not getting it where you want it, when you want it. Especially if we're growing flowering annuals, which is what we're talking about. You need it right now.
Exactly.
And so the only form that's responsible or makes any logical sense to use is monosilicic acid. The problem is with labeling laws the way they are, a lot of people are selling potassium silicate products and they're calling it monosilicic acid. So if you see something that says like a 003, meaning it has potassium in it, and they're claiming it's monosilicic acid, it is not. If it has potassium, it is a potassium silicate product. So when you look at Dune, it doesn't have an NPK value because that's not what we're providing. We're providing monosilicic acid. That's it.
Now, I did some research on that. I did a deep dive on monosilicic several
Very
years
good.
ago. And I found that, and correct me if any of this is wrong, but I found that so there are people that consume a ton of, feed their plants a ton of potassium silicate. I came from a company most recently that sold a lot of it. And we sold, I mean, an ungodly amount of it. And I'm thinking, like, what are these people thinking? But anyway, apparently, so like you were saying with other things like rock wool and whatnot, if you put potassium silicate in water, it will form monosilicic acid, but it's a equivalent I can't use the I can't speak. Anyway, it has there's a balance equation.
Equilibrium.
It forms an equilibrium, but the equilibrium is so far over to potassium silicate that the amount of monosilicic acid that is produced
Right.
is negligible. And so
Yes,
I think some
that's
people
true.
are getting confused because of the marketing,
Yes.
intentional marketing, because of the labeling, because of the regulations and stuff. And then they might look it up and say, oh, look, potassium silicate, it forms monosilicic in water. So I'm just going to use that. It's like, yeah, but did you pay attention to the decimal point? Because it's like a nanomolar is not a micromolar, is not a millimolar. Is like, this is not producing enough to be biologically relevant. So I think that's a huge point to clarify because I still see it to this
Absolutely.
day. People, I mean, obviously the folks that really get into the science understand, but there's a lot of folks that are still using a ton of potassium silicate and it's kind of wasting your money.
Well, and I'll be honest with you, when it comes to farming, I'm very cheap. Okay? Like, I'm choosing the cheapest possible thing to accomplish the goal. And in the past, this was many years ago, I was using a straight potassium silicate powder form. I'm not here to talk about brands or whatever. And I figured out a way in which I could temporarily create a monosilicic acid using pH and some what have you. Okay. The problem with that is that if you get the pH wrong, it's going to polymerize and turn into silica gel. And more than once, I clogged all my drippers in a room because I got the pH wrong. That's a real problem, especially as you scale up.
Yeah.
That's an expensive problem.
Yeah. Yeah. And if
And
that gets into your dab pump, it's a paperweight.
we got a real problem and an expensive problem on our hands. So
Yeah,
the thing
because
about
it turns into rock basically. Like you can't really get it out of there. It's just
it turns into these little gel blobs that clog
well,
up everything.
sometimes, at least with some of these products that I know, they can. And I'm not trying
Yes.
to flame them, but there's a particular product that I may or may not have not sold because I knew too much about it. But yeah, if it gets into your dab pump or into
Yeah.
any pump, I mean, it's basically your lines, everything. It's just
Yep.
basically turns into a rock, and
That's right.
then you're calling your sales rep bitching at him, and the sales rep, I don't know.
Yeah. And then you're going to spend a whole bunch of labor. And if you didn't lose plants, good job, but you're going to spend a whole bunch of labor and time cleaning all this out. So the thing about Dune is that it is monosilicic acid, but it is reacted with a particular plant, naturally occurring plant compound that prevents it from reacting with itself to form polymer and prevents it from reacting with things like calcium ions to form that cement that you were talking about. Because calcium silicate, if that reaction happens, calcium silicate is a refractory cement. It is a ceramic. It is not soluble. It's a problem, no matter how you look at it. So we react it with a naturally occurring plant compound that keeps it from reacting with itself, reacting with other ions, keeps it soluble, and keeps it very bioavailable.
And for the record, I've never seen anything happen bad with Dune, and I've had it around for a while. I've had some in my garage for my plants out back, and like you could have it. it's pretty darn, at least in my hands, is very stable.
Yeah, no, I was using it at a 60-acre hydroponic tomato greenhouse, and the growers were quite concerned because they had tried other silicate products and saw it react with their nutrients and were, let's say, resistant to the idea. And I had to prove it to them with jar tests and demonstrate, no, this is not going to cause those problems. And I used it for years in that greenhouse without issue.
Now, you do want to. There's a certain order that you have to do it when you do the tank
True.
mixing.
So the key point is dissolve Dune first in water. After that, you can add most anything that you want to it. I've used it in tank mixes with pesticides and fungicides and all manner of surfactants and what have you. The only thing that I don't tank mix it with is very concentrated calcium salts. That's the only thing. So if you have a calcium nitrate tank, don't put it in there. Put it in your Epsom salt tank. Put it in your NPK tank. If you're doing foliar feeds with it, you can mix it with damn near anything. But if you're doing what I was doing and mixing like heavy calcium salts as a foliar for tomatoes, don't put that in there. Do it the next week. Rotate it.
Mm-hmm. Now, here's an interesting little fact that I don't know that you even know this, but so a long time ago, gosh, this is kind of a rabbit hole, but so my hands got chemically burned pretty bad. My one of my ex-girlfriends bought the wrong type of soap, and it was actually dishwasher detergent, and she had put it in the hand soap dispensers, and it was still some soap in there, some hand soap, so it wasn't 100%. I used it on my hands, and afterwards I'm like, it smells a little bit like bleach. And I couldn't figure out why, because it wasn't readily apparent because it was a mix. And then we washed the sheets, and you could see my hands had bleached the pillowcases and the sheets. There was just straight white, like very strong bleach. That was just what was coming out of my hands, right? So it basically destroyed my collagen. My hands were old man hands, and every
super
winter,
high pH with that. Like it saponified the fats in your skin. Like
it looked like for a while, like for a year, like the slight bit of dryness in the air, my hands were, it looked like I was wearing red gloves on the top and the bottom. Like it was just bad. And when it would get wintertime and there's condensing atmosphere, right? And so very low moisture in the air, every single little crease on my hand would crack and bleed. Every little crease. So, I mean, it was horrible. I mean, it was, and here I am, I'm going out. Part of my job is to meet people and shake hands. And I feel like I got leprosy or something. It was bad. And I couldn't use it. No lotion would help because it just wouldn't absorb. Nothing would help. And then I was out at Green Coast in Hesperia, and I had a bunch of samples of Dune, and the samples weren't sealed and they had leaked, and it got on my hand. And instantly my hands turned into, they were soft as a baby's ass. I mean, it was crazy. And it just soaked in. And this is an off-label use. I'm not saying to use this, okay? But
we're not making any claims.
I'm not making claims. This is just anecdote. But it worked so well. And I looked at that and I said, oh my God, I've got to find a human safe version of this, because I mean, I don't want to. And ever since then, I got a monosilicic acid that is made for humans, and I put 8 drops of that into my water every day, and I have not had that issue ever again. It solved the problem. Huge thing.
I fully believe in the other stabilized versions for human consumption as well. Like it's great. It increases cartilage production, all kinds of stuff. Like silicon, stabilized silicon is hugely important for human health as well. Yeah. And frankly, if we're putting it into our vegetable plants, then we're putting it into people as well. So exactly. We're doing favors for people they don't even know we're doing for them.
Absolutely. It's a great product. I love that. I love Dune as a product for many reasons. Very personal. I mean, honestly, that was a lifesaver to me. So
that's amazing. That's very interesting.
Yeah, it was cool. It was a little learning lesson. I was like, okay. So now the human stuff is a lot more expensive because of the old tiny bottle of it. So it is what it is, but I do it. All right. So let's see. What did we talk about?
Let me ask you this. Yeah. Let me ask you this. You brought up working out before. Do you take like branched chain amino acids or any of that kind of thing?
Most of what I take as far as supplements is just herbal stuff. So it's
Okay.
just dried, desiccated, just nutrients, like
Okay.
in a powder form. I dump it in my blender drink. I do add a little creatine as well. I
Excellent.
started doing that more recently. I don't work out a lot, but as you get older, it's helpful to get some more protein in, and creatine's a good thing
It's super
for
good for your
that.
brain too.
Yeah, there's a lot of benefits to creatine. Your
Yeah.
brain, your hair.
Well, the reason I brought it up is so the other product that I kind of like to focus on for people, especially for plants that are under stress, whether it's from environment or viral pressure or whatever, blossom end rot for tomatoes, is Lumina, which is our amino acid product. And it does a number of things. Amino acids are the building blocks for proteins, right? So immediately the plants intake it and can build proteins out of it, which is building fruit, is building flowers, whatever they're trying to synthesize. They also are the building blocks for antioxidants, which kind of brings it back to that oxidative stress thing. And so they can tolerate stressors and still have incredible high quality produce out of them. And I've seen that with different viral pressure and environmental pressure, and as well as pesticide pressure, because when you apply pesticides, you're stressing the plant. You cause oxidative stress to the plant by applying pesticides. So if you tank mix with Lumina, you're going to alleviate that and still see great growth. So that's another one. And I really like to encourage people to put it in their calcium tanks, because then the amino acid chelates the calcium and makes it much more available and mobile throughout the plant. And it's the easiest way to use it. You just put the Lumina straight in your calcium nitrate tank. And we're talking about cannabis mostly, but both tomatoes and cannabis are calcium hogs. They love the stuff, and they really can't get quite enough of it in the environments that we put them in, right? We're demanding so much of them. So increasing the mobility and availability of calcium is key.
Yeah.
So
No, absolutely.
Lumina for that one, I'm seeing some pretty impressive results. We're doing some tests up in Canada right now where it's rectifying like discolored fruit, because when you see discolored tomatoes, it's really because they're overproducing reactive oxygen species, and it's bleaching the antioxidants, because the color from the fruit is from the antioxidants. So if you have too many ROS and the antioxidants can't keep up, and then you get this like blotchy colored fruit. So we're finding that feeding them Lumina is really rectifying that issue, making stuff sellable that they previously wouldn't have been able to sell.
Yeah.
Go with that.
So yeah, I really like what you said about amino acids acting as a chelating agent, because I personally think that they're basically the best chelating agent for what we're trying to do.
Yes.
You can chelate with a lot of different things, synthetic chemicals like EDTA, DTPA, and there's other ones, but they really don't do anything else other than make that nutrient bioavailable, right? But if you chelate with amino acids, they make the nutrient that they're chelating more bioavailable. But then when they get to their destination and they deliver the payload, now they themselves are also a nutrient that is being delivered to the destination. So to me, I think you can't get a better chelator than amino acids. And actually, even nucleic acids can also act as a chelator, if I'm not mistaken. But amino acids are just fantastic. Yeah.
And the way I like to think about the difference, the way I describe it to people is like, so let's just take EDTA, the classic, right? That is not a compound that the plant intakes.
Yep.
Okay. So yes, it's wrapped up the calcium ion. It's made it unreactive with other ions, say phosphate or sulfate or other things that if it reacted with phosphate or sulfate, it would fall out of solution.
Yep.
Because calcium sulfate is gypsum, that's not soluble. Calcium phosphate is hydroxyapatite. It's what our bones are made out of. Bloop, that's not soluble. Okay, so EDTA wraps it up, keeps it from reacting, but then when it arrives at the plant tissue, it just kind of goes bloop and like pushes it in, and the EDTA stays out. Okay, with amino acids, they wrap it up, and when the plant encounters the amino acid, it wants the amino acid. it's going to make protein out of that. And it goes, om nom nom, and eats the amino acid, and the calcium gets a free ride into the plant. It passes freely in there. Now, the other thing you have to remember, let's say a calcium is a free ion, the plant actually has to exchange ions, hydrogen ions, into the liquid to then get the calcium. Okay? And that calcium ion is competing with potassium and magnesium and the what have you, all the other positively charged ions. But when it's chelated, it doesn't compete with those. And when it's amino chelated, the amino is the beneficial Trojan horse of, oh, that come on in. We're taking amino acids all day. And then not only, it might not be immediately used. The amino acid is going to get transported in the xylem and the phloem because they're like, we need amino acids. We're trying to make fruit. We're trying to make flowers. You go up there, you're going to do that. And then when it gets digested and used, the calcium gets deposited. So it's not even to speak of the fact that amino acids are soluble over an extremely broad pH range, where DTPA, EDTA, those are there's a pretty narrow range. So, yeah, amino acids are the king of chelators for all of those reasons.
Yeah, and that's a great point about it going inside the cell, because it's not just dropping
Yep.
it off on the doorstep like Amazon. It's bringing it
Yep.
in, and it is a payload
Full
unto
service.
itself. It's full service, absolutely. Absolutely. Love it. Love it. Yeah, so, and just a side note about Lumina, I am always amazed at how many people fall in love with that product as a foliar. Now, you can use it in your tank, and it works great
Sure.
for all these other reasons we discussed. But as a foliar, I don't think there's a single product that I've had more positive feedback as a foliar. Heavy 16 foliar is pretty close. People love that as well, and I believe there's some good stuff, amino acids probably in that too.
Sure.
But Lumina, it's got a cult following. These people,
Well,
like, it's just,
I think it has more to do with the fact that it's such a rapid response.
exactly.
And humans, we're moving fast, right? Like, we're not as patient with the slower, greener life forms, right? So when you spray something on something and then hours later you go, good Lord, that's greener than it was before.
Yep.
I like that thing.
And everything, all the plants are praying like this. The leaves have got that fold to them where it just looks like they're just exploding. Like it looks like, man, they're just
It's like they're holding up a lighter at a concert.
Yeah,
They're going,
there you go.
woo!
They love it.
We
They
like
love
that.
it. And it's instant.
Yeah.
And you're having problems. You could be having any sort of stressful problems. You spray with
Whatever.
that. It literally is within hours, if not even less than an hour. And you go in there, you're like, is that even real? That's a real thing. Wow.
Should I
some more of
see it that fast?
Exactly.
Exactly.
Yeah. So
And
yeah.
and if you put it in there with trace minerals or seaweed or something like that, it just makes them more available too. So it's just a facilitator for plant health. And to kind of again loop back to the antioxidant conversation, all those amino acids are also precursors to antioxidant enzymes. So if you have a stressful event and you foliar feed with that, it's like you didn't have a stressful event.
And as long as this is our main topic here, I mean, we've gone down a lot of rabbit holes, but we are talking about, yeah, I think it is also important to note that a lot of the folks that were doing these pseudo sterile systems, in addition to not having terpenes, right? Because that's the most notable thing. I mean,
I think you mean cardboard terpenes. Is that what you
I've gone into so many farms and they've just been
Sorry.
running the unnamed entity that popularized bags of salts in this industry, and that's all they're running
fine.
with hypochlorous acid. And I have seen beautiful flowers, absolutely, but
Sure,
I've gone
of
up
course.
there and I'm rubbing the stems, and I probably say this in every podcast, but I'm rubbing the stems and I can't smell anything. Again, people who are regular viewers are tired of the story, but I thought I had COVID because I can't smell anything. And the plant looks so good, it didn't register. I was like, how could you look that good with that many trikes and not have any terpenes? My brain was like, no, you got COVID or something. But you add back
That's dark.
you add back the beneficial microbes, you get these terpenes back, but also, and correct me if I'm wrong, another problem with running straight salts, pseudo-sterile, no beneficial microbes is shelf life. And when you if you think about shelf life, it's an oxidation event, right? So that's basically what's
Yep.
happening with your shelf life. It's oxidizing. And if you don't have
That's a great point.
a bunch of antioxidants in those nugs, then the oxygen it's going to destroy something. And if you have a ton of
Yeah.
antioxidants in there, it'll break down the antioxidants before it breaks down your particular favorite antioxidants like THC and cannabinoids and terpenes.
I had never, to be honest with you, I'd never considered that. 100% logical. You don't have enough antioxidants in your product as you're doing an oxidative process to your produce. It's going to oxidize faster. I don't know what to tell you.
Yeah. and it compounds the problem, because if you don't have terpenes, people aren't going to like your product as much. So it's going to
Well, for sure.
it's going to sit on
Yeah.
the shelf longer. I mean, in the old
They
days,
might buy a one.
exactly. In the old days, when you had the deli jars, like, it would never get sold because you could open it up, smell it, and be like, "There's no terpenes, forget it."
Depending on the state that we're talking about or the whatever. But either way, you might buy a thing once if it looks good. But if it doesn't smell good, if it doesn't taste good, it doesn't freaking matter.
And then it sits on the shelf longer, and it has less antioxidants, and now your shelf is gone, and
It's dead.
it can ruin you. So I have personally gone into a lot of salt farms, we'll say, and just handed a bottle of Tribus, handed them a little bit of some of the other ones, but like, they come back and they're just like, "Where have you been all my life?" It's like, and
So-
the thing is, you don't need much. It's like a half a mil per gallon, like once a week, maybe a mil.
I have a good story on that. When I was a head grower in Washington State, and again, I was doing some hybridization projects. I'm trying to hold on just a second. I need to remember the hybrid that I was working on. I called it Taiway 99. Okay. And it was a cross between Ace Seeds Golden Tiger, which is Thai Malawi. Okay. And I crossed it with Cinderella 99 to bring down the flowering time without removing like the great sativa kind of high, right? And so it was such a good cultivar. I mean, Cinderella 99 is a fantastic, stabilized, consistent breed, great producer. The aromas are fantastic. The type of high is exactly what I like, a stimulating, creative high. And then the Golden Tiger is a terrifying beast of a sativa that is unpleasant at worst, good fun at best if you have an activity planned. I'm not kidding. Like, Golden Tiger it's not to be trifled with. It's not for like people who don't like sativas. They're gonna have a panic attack. Okay, so I crossed it with C99 to like bring down the flowering time, make it a little bit more of a commercial variety. Okay. So then I found some keepers out of it, which, by the way, I found some non-keepers out of it, which were even more fun because they did induce panic attacks. But that's another story. But I found some keepers, and then I shared the cuttings with a fellow company that was out of the Skagit Valley in Washington. And this guy was one of the best growers, like genuinely one of the most scientific, like everything he did was very smart and supported by evidence. This wasn't bro science guy, right? He was getting north of 4 pounds a kilowatt every time, regardless of the variety. He came back to me and told me, "James, I'm getting 5 pounds a kilowatt out of the Taiway 99. And I went, listen, I know you're not a liar, but like, that's unreasonable. And at the time, I was doing consulting, but I was also the sales manager for that company. So I was selling all of their product. And I had run their facility when he was on vacation. So I knew how many lights they had, how many rooms, and all of that. He wasn't fibbing. Okay. He was getting 5 pounds a kilowatt. But then he came to me and he said, "I don't understand why your herb is smellier than mine." And I said, "Brother, I've been telling you this. Like, it's the microbes, man. Like, You're just using salts, and I don't disagree. That can be a productive method. Obviously, you're out yielding what I'm doing. We're growing exactly the same clonal variety.
Yeah.
Exactly the same clonal variety. I gave you these cuttings. Mine smells better. And to be fair, I had a shittier facility than he did. Therefore, I wasn't getting quite the yields. I was getting like 3.5 pounds a kilowatt. All right. This dude's pulling 5. But his stuff didn't smell like mine did. Microbes.
Yeah. Microbes.
Organoleptic properties. There's so many fancy molecules that microbes make that make things smell better.
Yep.
And finally, I got him. He resisted it for literally a couple of years. I told him this. And then finally he goes, fuck it. I think you're probably right. I might be the microbes. And I went, welcome to the party, brother. Like, you might even get better yields now.
Yeah, yeah.
And so we started incorporating trichoderma and bacillus microbes in his program. And yeah, lo and behold, it smelled better.
Hell yeah. Awesome. Awesome.
Yeah.
Well, as long as we should finish out our conversation with the product that you use at the finish.
Okay.
So
well, as long as we're talking smell, right?
Yeah, that's what I'm saying.
Okay. We have a product. It's called Tundra. Because of labeling laws, I'm going to sit here like I'm on a camera being held hostage in a room where I can't say the thing that I need to say. Tundra is not a PK booster. It has other compounds in it that we don't put on the label. And they induce a stress reaction in the plants and makes it increase cannabinoids and terpenes dramatically, like a lot, double-digit percentages. Can't tell you why. Call me on the phone if you want to know.
There you go. There you go. Or call me too. I may or may not know. Yeah. So tell us. I know you can't talk about the molecule, and I'm not sure if you can talk about the pathway exactly or not. But
yeah, we can do that.
Yeah. Tell us a little bit about how this works, because honestly, this is another product where I have had some just raving reviews about this product.
Brother, I've had great results with it in other plants as well, with strawberries and tomatoes and things like that. Like, okay, so there's some compounds in Tundra that tell the plant that there's a stressful situation happening. Now, completely shifting gears, nothing to do with what I just said. There are 2 main stress chemicals in plants called jasminates and salicylates. Okay. So one of them is mainly focused on like insect pressure, and one of them is mainly focused on like microbe pressure. All right. But if you induce those pathways, if you tell the plant at that high level, there's an organism stressing you right now, they will have a response that is a massive biochemical response where they're going to increase antioxidant production. They're going to, in this case with this plant, increase terpene production, increase cannabinoid production, because they're trying to protect themselves against whatever it is. It might be UV or insects or fungi or what have you. There are some compounds like that in Tundra, and it triggers the plant to defend itself. And it defends itself by increasing cannabinoids and terpenes, which we love. That's what we're after.
Absolutely. And for those of you that want to do some homework, these pathways, one would be systemic acquired resistance, and then the other would be induced systemic resistance. And I highly encourage you to do some homework on that one, because this is amazing stuff. And when you understand those pathways, a lot of what we're talking about relates to that. The Dune would be an SAR, systemic acquired resistance pathway, whereas Tundra is the ISR pathway. And I mean, you want to understand these things, because this is what we're all about in this industry, is really understanding these pathways so we can get the best product. And in fact, I think we're going to have James back on here, because I think we could do a whole episode on ISR and SAR. Yeah. I think we could do a whole episode on just honestly, like, I don't want to say pesticide, IPM. We could do a whole episode on IPM, like very non-toxic methods for achieving better results than using the nasty
Yeah.
chemicals. And before I forget, just to be clear, the chemical may the unnamed molecule is not a synthetic molecule. It's a natural molecule.
Right.
It is not one of these toxic things that you never want to put on your plant. It's nothing like that. It's very safe.
That's an excellent point.
You're not going to pop dirty. This is a very plant friendly, human friendly, testing friendly molecule. This is not something like those molecules that we all know should never be used on these plants. So just want to make that comment.
Naturally occurring plant hormone that triggers the results that we are after.
Exactly. And no toxic byproduct, nothing like that. So yeah. So I mean, I guess that kind of wraps it up. I guess what I would say now is just if you have any questions, obviously go down to the comments and let the fist fights begin. I'm sure there's going to be a lot of controversial things in there. So the comment section could be the biggest entertainment of this entire video. Or if you choose not to be a troll or either direction on the comments, you can always pick up the phone, give us a call. You can call me at Green Thumb. Obviously, you reach out to James. James and I talk a lot, and we certainly distribute their products. So if you need anything, give us a ring. Happy to talk about it and get your grow going in the direction that it needs to go. That's all we're here trying to do is help everyone achieve the maximal success.
Hey, listen, happy plants make happy people, make happy plants make happy people. That's what we're interested in. And even if it kind of ruffles feathers, that's fine. That's fine. But if we end up with happy plants and happy people, that's fine.
Could have said it better. Myself. Well, James, truly from the bottom of my heart, thank you for coming on to this episode of the Growers MBA podcast. We're definitely going to get you back on sometime soon. And with that, enjoy, and we'll see you next week, the next episode.
All right, brother.
All right.
Good to talk with you, man.
All right.
Bye.
Bye-bye.